it corresponds with confidence. So that alpha, that 5% tucked out in the corner, that's the opposite of confidence, which is the rest of the null curve. 95% in the null curve is the confidence. Type 1 error is out here in this curve, the tail, that's the type 1 error. Type 2 error would be that little shenanigans there. The rest of the other curve is called the power of a test. The power of a test. You'll very often hear about statistical tests that are underpowered. When they're underpowered, it's generally due to very, very small samples. Very, very small samples are underpowered because beta is too big. And this is the problem, Carly. I'm going to mention this for the first time today, and I'll keep mentioning it for the next half of the course. Remember how Carly always likes to go with 99% confidence, and I love that? The problem is, as confidence goes up, power necessarily has to go down. Now here's why. In other words, as type 1 error goes down, type 2 error has to go up. Imagine these curves right here. Imagine these curves right here. Yes? Now remember, this is type 1 error. This is type 2 error. Assuming you put your cutoff right here, this is actually the chance of type 2 error, that whole curve. If you want to increase, now this might be confusing right now, and I apologize for this. I have a whole quiz devoted to this in about 2 weeks. If we want to increase confidence, we have to pull this way, right? This is at 95%. To make it at 99, we have to pull it further this way, yes? Well, you see if you do that, that does make this get smaller, but it also makes this get bigger. That's the problem with driving confidence up as large as you want it. If you want to drive confidence up as large as possible, you're unfortunately driving down the power of the test, which means as false positives rates go down, false negative rates go up, and conversely. I have a whole quiz devoted to this soon that you guys can get into and look at. And it makes a lot more sense with an Excel spreadsheet that you can drag sliders on. It makes a lot more sense. Please, McKinnon, please.
So I just want to get this straight.
Yes, please.
So if you say less power, does that mean it's just less significant, statistically significant?
Can you hold that thought if you don't mind till next time?
Yeah.
I want to answer that in context. It's a much easier question to answer in context. Not to push it off, but I want to answer it properly, and I can't do that in 5 minutes. I will do it properly in the first contextual bit, though. Thank you. Yes, thank you. Please. Linda.
So you said type 1, type 2, so that would be H1 and H2.
Yeah, the idea of H1, H0 is the type 2 error actually deals with H1, where the type 1 deals with H0. Now, again, similar to McKinnon, let me get back into that next time, if you will. It'll make a lot more sense next time, I promise you, in context. I'm trying to be too general with this image, and I think I've done too much by actually going as far as I did. It is visual, and I've got a much better Excel spreadsheet that does it visual and dynamically. So you can actually take this line and pull it side to side and see what happens. We'll come back to that in a couple of weeks. Veronica?
Well, so do scientists just not try to replicate typically if it's over that 5%? Because I'm struggling with the fact that they're still, even though it's over 5%, and it's not.
There's something there, maybe.
Yeah.
Yes. Di sent me an article in the last term of 243 that said there is a horrible lack in the journals of true negative results. There's no shortage of true positive results because there's no shortage of false positive results. And roughly 1 in 20 is going to come back as a false positive, 19, 20 come back as true positives on average over time. But people tend not to report on big p-values, which would be true negatives. Perhaps false negatives, but definitely true negatives in a lot of cases, because that's not deemed newsworthy enough. It apparently doesn't mean as much to say, coffee does absolutely nothing for your metabolism. Then, coffee is great for your metabolism. You see the difference? The second statement is a positive test result. Coffee is great for your metabolism. That's the positive test result. Coffee does nothing for your metabolism. That's a negative test result, but it might still be meaningful. And the error analysis of it might be worthwhile, but nobody's doing it, unfortunately. Thank you. Your concern is warranted, and it's in the literature, documented, noted. It pisses off a lot of researchers. You're one of them. Yeah? Let's stop there for today. That's about all we got to do from this. I know we didn't get to every single sheet on the slides. The last couple slides are just a synopsis. If you want, between now and Thursday, the extra resource page on this topic is rich with examples, rich with more of these. It also answers Veronica's 5% question. I think, I could be wrong about that. It might be the next homework enrichment set, maybe, but I think it's in there. So if you want to look in there and see more examples of this, please do. Yes, please do. We'll catch you guys on Thursday.
My bad. I have issues
Keep up,
with
my friends.
you.
I got some questions today. Keep them coming, okay? I love them. I love them. I don't know. Oh, I love this. So you've got 39 to 40%, or 39 to 36.
For him, because I'm struggling to find articles that have the margin of error.
And there's no difference between them.
I go through the majority of the first part, but the last part, I was like, I'm just so lost.
I spent like half an hour looking for articles last night.
Oh, the source.
And I'm like, okay, I'm so tired, I just have to go
This is fine. This is fine.
figure this out.
I'll write this, so I'll know this. So this is fine. In the future, what I'll have you guys do is copy the hyperlinks into your documents, but don't worry about that. You can't copy it onto your. Don't worry about it, because then I have to take this. I trust you. I trust you. I think Alvin looked it up, my friend.
Okay.
Hi. Good for you. Good for you with that last thing. That was fantastic.
Okay.
Seriously, that was that negative. That why are there more bigger p-value results? I don't know. Pisses me off. Good for you. Capital P. Pissed.
So I'm having a hard time finding articles with margin of error.
Gallup polls always have the Quinnipiac, Rasmussen, Gallup. Yeah.
I found them in my next class.
Isn't
like
that
10 minutes.
pathetic?
Okay.
Isn't that pathetic
Yeah,
that you're having a hard time finding margins of
I
error?
spent like 40 minutes last night.
Ridiculous.
And
that you
I was
can't find
typing
margins
in
of error.
all kinds of
It's
things.
ludicrous. Now, what's kind of cool about this is these automatically have margins of error built into the p-values. If you got a small p-value, it means you're outside the margin
But
of
you
error.
don't, I didn't find any of that type of thing on them either.
What I've gotten
It just
around,
says-
what you can do in Google is just put in p less than 0.05 and see what comes up.
Okay.
And then just backtrack. There's also a Google Scholar link that's kind of fun. You can click not just web, but Scholar. It'll give you scholarly PDF articles. That's where I found quite a few of your guys' stuff.
Okay.
But yeah, by all means.
And I have one other question that
Let me shut the camera down. Go ahead. Go
take
ahead.
more time than this.
Go ahead. We can try.